Okay, this video starts a new lesson. It's going to be very similar to what we have been doing for the last few days, but now we're going in reverse. So in the last couple of days, we've always started these situations by saying we know the lines are parallel, and let's try to show something about an angle pair. Now we're going in reverse. So I'm going to give you an angle pair, and we're going to try to show that the lines are parallel. And we kind of start out the same way. We're going to start just by knowing the corresponding angles postulate. We assume this. So that postulate says if I know that the lines are parallel, all the corresponding angles are congruent, and it works the other way too. If I can show that corresponding angles are congruent, then I know the lines have to be parallel. So in this particular proof, we're going to try and get to a point where we know that 2 and 6 are congruent, or 1 and 5 are congruent, or 4 and 8 are congruent, or 3 and 7. If I can say that in my proof, then I can, because of the postulate working backwards from what we've been doing, if I can get to that point in the proof where something like 2 and 6 are congruent, then I know the lines are parallel. It's going to have a different feel, and you really need to focus on the reasoning behind each step here. So here's what we're going to start with. We're going to try and say if I know that 3 and 5 are congruent, so I know right now that 3 and 5, they are the same. I want to be able to show that that's enough to say the lines are parallel, but the only thing I know right now are that I can say that lines are parallel if corresponding angles are the same. I know that sounds a little confusing, but we still need to come up with a game plan for that. So here's the idea. I know that 3 and 5 are the same. One way I could look at this is because of vertical angles, I could say that 3 and 7 are the same. I don't have to use that pair. I'm just going to use that in my proof. Okay, so I know that 5 and 7 are the same. I know that 3 and 5 are the same. My question is, does it make sense to say then that 3 and 7 are the same? Is there a logical path to say that 3 and 7 are the same? And if there is, 3 and 7 are corresponding angles, and if I read the postulate backwards, if corresponding angles are the same, the lines are parallel. And that's kind of the mindset for this. Okay? So our proof is going to look a little different. The steps are going to be in a little bit of a different order than what we've been used to, but we're still kind of using the same ideas. Okay, first start by writing out the given, and that is that angle 3 is congruent to angle 5. These are alternate interior angles, and we're trying to get to, at the very end, we're trying to show that that means the lines have to be parallel. Okay, I said if 3 and 5 are the same, I also have a nice connection that angle 5 and angle 7 are the same. They're vertical angles. So that theorem says that they have to be the same. Now in our last series of proofs, when we had this kind of chain reaction, we said, oh, there's a shortcut there. I can now just say, let's cut out angle 5 and let's just say that angle 3 is congruent to angle 7. Whenever we kind of did that shortcut there, that chain reaction, that was the transitive property. Okay, now this is where things are going to be a little different. Okay, in step 4 in this case, but it's not always step 4, but the last thing that we always write down is what we're trying to prove. And now what we're trying to prove is that the lines are parallel. So again, go back to your picture. Okay, what we have just done is we've shown, let's see if I can get a different color here. I'm not sure if that's going to work. There we go. Okay, what we've just shown now is that 3 and 7 are the same. They are corresponding angles, and if corresponding angles are the same, lines are parallel. So that's kind of the rest of this proof is now saying that, oh, I know that the lines have to be parallel because that's what the corresponding angles postulate tells me. If corresponding angles are congruent, the lines are parallel, and there's why. Okay, so it's got a different feel, and the proofs are going to end differently now. Normally at the end we always said, oh, transitive property or congruent supplements theorem. Well, the proof is formatted a little different. We're trying to prove something else. So now generally at the very end we're going to have one of our main theorems that we use at the very end, but that transitive property or that congruent supplements idea is still going to pop up there. It's just going to be in the middle of the proof, I would say. So that was kind of our intro. I know there's a lot going on there. We'll stop there and try a few others here down the road.